Hey class, it's Daryl. This week's report is a joint mission between Uranus and Neptune. So here we go. So here's earlier today, Uranus and Neptune in relation to where the Earth is right at the moment. In the night sky, Uranus is currently in the southeast and Neptune is in the south. You can't, unless you're very good at picking out planets against stars, you can't really see Uranus and Neptune. You just can't see at all unless you have viewing equipment like a telescope. And since I am neither, since I don't have a telescope and I'm not good at picking out planets against the stars, no, I didn't see them in the night sky. As for size, Uranus is slightly bigger than Neptune. Uranus's equatorial radius is 15,759 miles, and Neptune's is 15,299 miles, so it's really not that big of a difference, but it is still there. On the other hand, Neptune is thought to be more dense than Uranus is, and I will get to why that is in a moment. They're really not that massive compared to the gas giants, but they are still a lot bigger than the Earth is. So, both planets are thought to be built kind of the same way, with like a fluid, icy core mostly made up of like methane, water, ammonia, a atmosphere made up mostly of helium and hydrogen and methane. But it is thought that Neptune might be more dense. It's thought that it has about an Earth-sized solid core. In comparison, you can see here it's a little bit bigger than Uranus's is, which I looked up how they find planetary density, how they estimate that, and it sounds like it's usually dependent on observing gravity, how it affects a spacecraft that goes past the planets, obliqueness, which is how much the equator bulges, and seismology, if we can get it, as well as some very good inferences. So flying Voyager 2 past these two planets kind of helped collect that data. We can't land anything on planets, but on any surface, since there isn't really one to land on. But the data sent back from how gravity affects the spacecraft kind of helps us understand their different layers in the density of the planets. It's also thought that Neptune has a second sort of element helping out with the color of the planet in comparison to Uranus, since they do have a similar atmosphere, but Neptune is a lot bluer, so we're thinking there's another element that's at play there. So as for the rings, we have Uranus has 13 rings, and Neptune only has 6. Both sets of rings were kind of discovered the same way. Uranus's were discovered in 1977, when some scientists were observing the star SAO 158687 and found that the light kept getting blocked by something, and it turns out that, yeah, Uranus has rings. And Neptune's rings were kind of discovered similarly in the 1980s. It's thought that the rings are a lot darker and that they're made up mostly of like rock and dust. And most of them are ring arcs, which is the clumpy bits that you can see here. So for fascinating facts, I'm going to start with Neptune. I really like Neptune storms. I specifically like the Great Dark Spot. The original one was found by Voyager 2 in 1989. It's thought that it had kind of a similar weather system and size to Jupiter's Great Red Spot, but with much more severe weather. It clocked wind speed up to 1,500 miles per hour. It was flanked by white companion clouds that were thought to be kind of similar to orographic clouds that are around mountains on Earth, most likely made up of methane ice crystals. And it's been found since then that white companion clouds always kind of show up when a new great dark spot is about to come around. When we first discovered the Great Dark Spot in 1989, a little while later we used Hubble telescope to try to view it again and discovered that it had all but disappeared from the southern hemisphere, and now there was a brand new one in the northern hemisphere. And since then, that one has also disappeared, and we recently discovered some bright clouds showing up on the equator in 2015, and a new dark spot was reported and confirmed by May 2016. So as you can see, it's not really that noticeable, it's not really that dark, but it is stable, and it's been in about the same place for a couple months now. So we're thinking it's going to stay around for a while. As for Uranus, so Uranus has 27 moons. Most of the things in our solar system most of the celestial bodies are named after different figures from Greek myth, but all of Uranus's moons are named after Shakespeare characters or Alexander Pope characters, rather than Greek mythical figures. So the 5 largest moons are Titania, there's Oberon, there's Umbriel, Ariel, and Miranda. The other 27 are kind of hard to spot. They're a lot darker and they're a lot smaller, the smallest being about 10 miles in diameter. They kind of help shepherd the rings, as you can see here. They're pretty small. My favorite is Miranda, just because of the really funky forms that are all over it. There's theories that maybe she was destroyed and reassembled in the past, or severely damaged and eventually froze back over. So, should we continue to explore Neptune and Uranus? I think we should. We don't know really anything about it. Most of what we have are just guesses. We haven't really been able to observe them all that closely like we have with Jupiter and Saturn. And it sounds, from what data we do have, they function more than a little bit differently from the other planets that we've managed to explore or collect data on. So I'm wondering what we could learn from them. And actually, there's a doctoral student who was recently awarded a grant. His name is Joshua Tollefson. He was recently awarded a grant to study Neptune's atmosphere specifically, and I'm kind of curious to know what sort of data he brings in from that. So here are references 1 and 2, and that's it. Thank you.